Kirchoff's laws are essentially these two. So this one says that the sum of all of the voltage drops in a closed circuit is 0. And of course these can be signed, so you can have positive or negative drops depending on the direction. And this one says that in any junction, the sum of the total currents is also 0. So the currents can be signed as well. So for example, here we can assign the currents going into the junction as positive, for example, and the currents going out as negative. So in this case, I1 plus I4 would be equal to I2 plus I3. So another way to think of this one is the total current going into the junction is equal to the total amount of current going out. So here's an example problem of Kirchoff's law. So if we have a battery here with 3 resistors, and we'll say this one is 2 ohms, and this one is 1 ohm, and this one is 3 ohms, and this is 10 volts, then, well, you probably learned in honors physics how to use equivalent resistance to get what it is in a parallel resistors and then add these two. But if we just go back to Kirchoff's law, we can see how essentially every circuit can be solved with these two equations. So if we say there's current going this way here, and then this way here, and this way here, and we say this one is I1, I2, and I3. So from this equation we get that I1 is equal to I2 plus I3, and then if we do the loop rule, we have 10 volts is equal to 2I1 plus I2, and if we go along this loop, they also get this equation. So now we can substitute I1 equals I2 plus I3. So and then we can solve this equation.
Alright, I think that's alright. Now we're going to talk about a special type of circuit element called an inductor. An inductor is represented by the letter L. So if we do the Kirchoff loop equation for this LR circuit, we get, if this is V, we get V minus IR minus L di dt is equal to 0. Where di dt represents the amount of current flowing through the inductor at any one time. So now we can solve this differential equation for I to get a formula for the current going through the circuit.